Hello all, welcome to Ambari Cloud YouTube channel. Today, part of Ambari Cloud LLM ebook, I'm going to walk through workflow of a document search. So if you're aware of many projects lately, people are building on document search using agentic or RAG based all the stuff. And then I will walk through what are the things one should prepare or learn to build a document search using LLM. You may ask, why not Elasticsearch, right? Why LLM based search? Elastic is a key value pair, right? It reads your document and builds the indexing and all the stuff. But you're querying your document, but it doesn't provide you context related information, reasoning or summaries, right? And bringing multiple documents, joining, those advanced features you won't get in Elasticsearch, basically simple key value based search engines. So that's the reason we're all moving towards large language model search. So the advantage of using this document search using LLM, right? It enables large volume of documents, right? You can load many documents and you can store in a vector store and then you can retrieve and all that stuff. And then, once you store these documents in an embedding format, then it allows you, semantic search, right? Similar queries, similar documents, those kind of things, you can do that. And also when you build these document sets, if you want to send the whole documents, then you will get a token issues, right? LLM has some restrictions. So then in order to do a document search, we need to do page split and then chunks and overlaps. That way, you can build an easy solution and also you won't get any token limitation issues. Then when you're using a combination of retrieval document chunks and LLM augmented RAG, right? It provides you a better solution, reduces the hallucination, right? That's why in the context aware build related documents. So you store your documents and then you give the document to LLM saying that, okay, this is my document, and then do analysis. So LLM with this knowledge and along with your document, and that's your document, and then it provides you the proper context aware human-like results, right? And then it's dynamic and flexible. It supports variety of use cases, right? And not only that, for example, you can do customer support documents, and we are working on one project where we load all the customer tickets, and then if anybody will open another ticket, we will look at similarity tickets, and then we provide a summary based on the history. Then we read the similarity documents and send it to LLM, and LLM creates a summary for us, right? Then, we can also use a similar the SQL sets too. So the workflow bridges raw documents data with advanced capabilities LLM, enabling powerful search and response mechanism tailored to modern AI application. So basically human-like search, right? Context aware, those things you want to build, you're going to use LLM. But in order to build this document search, right, we have to follow some procedures, right, and steps, and we need to learn those. And so for that, we're going to use a long chain framework. First thing is we need to learn how to read the documents, right? There are, text documents, web pages, Parquet files, JSON, there are, many document readers. So we should be aware how to read those document reader APIs. Then once you read the document, then you need to know how to split the pages, right? Once you split the page, then after that, we're going to know how to split into chunks. Then we're going to learn about how to split into overlapping. So overlapping allows you to do a context aware between two paragraphs. Think that way, right? Let's say if you break a page into chunk, and then if you ended with abruptly, then another chunk start with without any proper start, and then you get confused. So with overlap, right, we are basically associating these chunks together. Then it enables more contextuality. And then once we're done, then we're gonna embedding, right? So we're gonna convert into vectors, right? And there are different tools available, but we're gonna use OpenAI to convert into vector. So vector is basically, dense vector, sparse vectors. So basically convert into your text into numbers, right? And different dimensionality and easy to store. Then we can, when we store these vectors and then related documents, we can easily search based on the vector search. Then we're going to learn about vector storage, right? How to store these vectors, right? More popular are LLMs. Then Postgres is also popular lately. So basically, whatever Postgres database you have, if you extend it with PG vector, then you can store vector stores, and it also does the similarity search and all those things, different based on your indexing. Then then we need to learn about query processing in the vector store, right? Let's say you ask for, okay, show me orders, right? Or show me invoices in March 2023. So your prompt also convert into vector, right? Then it goes to the vector store and then run the search on it. But while you're doing that, right, sometimes you may want to, your prompt need to be rephrased, right? Or, of course, initially we're going to learn about that based on the search on it, then get the query and get the documents. Then you send it to LLM, and then LLM, does the processing, then whatever you're looking for. But to improve the performance and also reduce the hallucinations, right? There are different things available when you're doing the querying. Multi-query retrieval, it will going to retrieve multiple documents and multi-query way document retriever, or you can rephrase and retrieve, right? And then it going to retriever, and you can also have multiple retrievers, different way of if you have let's say your data is stored in a different formats in the different, or maybe different storage vectors, right? Vector stores. Then you can use an assembled retriever. That means you improve the performance of your query. Then let's say you have a multi-query retriever or maybe an assembler, or if you get too many documents, then you can do re-ranking, and re-ranking will, I want to, let's say you have 30 documents retrieved, but you don't want to send all the 30 to LLM because it's cost you more because of the token issues, right? So you can do re-ranking. Then say, I want to only, based on your re-rank theory or setup or method, you can tell what you want. Okay. Then you need to learn about prompting, right? People use say prompt engineering. I don't believe on prompt engineering. There's nothing, it's not engineering. It's not. You write prompts, and then you ask for rephrase. Then maybe you will ask multiple prompts of the same prompt, and then you learn about how to query the LLM. So direct prompt, or you can also a self-ask prompt. Basically, in a conversation, right, happens. Then within the prompt, then chain of thoughts prompt, it's kind of a asking questions, and then can I do this? Can I don't do that? Then back and forth kind of model prompts. Then we're going to put all together in the RAG architecture. Retrieve, right, from the storage. In order to retrieve, you need to, of course, split it, chunk it, overlap it, right? Then embedding, then storage. Then once you once you retrieve, you send that information to LLM, right? Basically, we are sending to LLM saying that, hey, LLM, you're an expert of things, but I know, hey, I'm giving you some additional information because these are my documents. Using these documents, using your experience, and of course, and based on the prompt request, it's going to generate the answer. So remember here, it retrieves your documents because that is your company knowledge or your knowledge. LLM doesn't have that information. And you're going to send it to LLM. It's called argument. Then we will also tell the prompt, we will give instruction to the LLM saying what to do, what to not to do. And then when you go to even agentic agentic models. They're even supervisor, researcher, expert, and all kind of things. You can do that. Once you do that, then you will get answer. So the goal of final answer, we need to get less hallucinated. In order to do that, we're going to do this RAG architecture. Then once you learn about this RAG architecture, then you're going to convert all this into agents, right? And then self-querying, then agent talking to another agent. Then if the answer is not correct, going back to previous agent. So those things we can build later, right? So document read, split, right? And embedding, store, and then query processing. Then within the query process, there are different ways of doing it. We're going to learn all those things: retrieval query, multi-query, rephrase, self-query retriever, NSM retriever, re-ranking, all those things we will look at it. Then also we're going to look at the prompting, different ways of doing the prompting. Self-ask prompt is commonly used, and then again, depends on your architecture of your application design. Then eventually, augment, right? So LLM augmentation is basically, LLM knows everything except your documents. So that means you're giving to LLM, hey, these are my context. And based on my context, based on my prompt, give me the answer. If you ask the LLM, give me the answer for a prompt, it will give you some answer. But it doesn't know anything about the invoice. Let's say, for example, I want to ask for, show me all my invoices in 2024, right? But my invoices information is stored in my vector store. My invoices are in PDF format. I need to split those invoices and chunk it and overlap it and put it in vector store. Then we're going to ask the LLM, you know how to read my documents, how to analyze the documents, and then, these are my documents. And these are my vector store. Give me all the 2024 summary of my 2024 invoices. But my 2024 invoices are stored in my vector store. So that is the context aware. That's what we're going to build it. So if you look at here, right, you're going to load the documents, right? And so basically whatever the directory you're in, then whatever the format it is, then you're going to split it. So here the load documents can be your web page, or your JSON, your Parquet, your Glue catalog or tables, all the information. Then we're going to split into pages, right? And then, we're going to chunk it and overlap the chunks, right? And up to here, right, you don't need a LLM, anything. Then you're going to need a model to embedding. It can be local model or maybe our free models or OpenAI. Then you're going to store into vector store. And vector store can be your Postgres vector, cloud or Pinecone. There are many. Or for testing, you're going to use local memory-based vectors. Then once you're done, then you're going to replace with the real vector store. We're going to walk through a Milvus and a Docker-based, and then we'll also look at the Postgres. Once this is a pipeline, this is behind the scene. Now here, when you load the documents, sometimes the documents might be already there. You're going to delete. So then that means you want to prevent the duplicates, because otherwise unnecessarily explodes the vector store. Then you'll get a duplicate documents when you do search on it. So we don't want to do that. Then our documents modified. Then we need to replace the existing document. So all this happening in this pipeline, right? And now once the vector store ready, right, you're going to build your application, right? And there are, for example, one of the application we built is the patient-doctor conversation. And once the conversation done, we store in the vector store. The conversation data is in a file format, which is first audio, then audio to text, and the text is stored in the vector store in embedding. We follow that, all this here. Then once we actually store, then, we ask a question saying that, okay, show me the, particular doctor conversation on particular time with a patient, right? We have a metadata of the patient name and doctor name and date, time. And then it retrieves that particular information. Then we will ask the LLM basically summarize this conversation, right? And while we will ask. Then we will also send another additional information saying that while you are doing the summarization, of course we give the conversation, while you're doing the summarization, okay, this is our rules for the ranking of the doctors, right? And they might have some, rule. We will send it to you. Then LLM reads your conversation, the doctor-patient conversation, and summarizes it, and then checks the tone, look at all the words and all the stuff, and then generates the answer. Okay, so that's how. Then we're gonna extend that one, and in the conversation, the doctor and patient, they're talking about the disease or issues without the patient, and what medicine they are using it, right? And then then the LLM in another route can analyze is medicine and disease mentioned by doctor are relevant, and is this correct medicine, right? And then is there any other alternatives, or is this medicine is bad, or what are the side effects, and all those information we can analyze through LLM, right? And then once the answer comes in, then we will send it to the doctor and then approve the summary. And then once we approve the summary, the rank goes to the, whatever it is. So you can build this kind of thing. And then we're also working on the summary of ticketing system, right? So reduce number of support users. So someone submit a ticket and then automatically with the summary, because we will store all the existing tickets in the vector store here. So this is how in a document search system. And then we're gonna develop this one in the simple stick RAG model. Then we can also add CAG, basically, adding more memory information, all the stuff. Instead of retrieving, if there are small documents, why we need to store in embedding, we can directly call from the file system and send it to here. So if you have, some documents need to be in vector store, but tiny documents don't need to be in the vector store. Right. So these are the things you need to learn to build a robust document search application in LLM. So once you're done, you're going to convert into agentic model. So that way, the whole industry is moving towards agentic, and it's easy, right? Once you learn these there's and coding and all the stuff, you can do it. Okay, that's all about the workflow of a document system. And then I'm going to walk through later the documents and how to then how to create the document. For example, you have a text data, how do you want to create, then how to do page split, then we're going to do how to do character split. So then later, of course, embedding, then how to store in vector DB. These are the things we're going to walk through, and I'm going to set up these videos soon. Okay. Any questions, reach out to me, skondappally@ambaricloud.com. Thank you. Thanks for listening.